Hello everyone. I welcome you all to JK Tech Solution YouTube channel. Today in our channel, I am going to walk you through the parallel plate capacitor design using ANSYS Maxwell. So before getting into our mathematical calculation, we need to know what is meant by parallel plate capacitor. A parallel plate capacitor is nothing but it consists of two long metallic plates which are separated by a dielectric or else an insulator. So here we have two plates. In the positive plate, we will be giving a positive charge, that is plus Q. And then in negative plate, we are going to give a minus Q, that is negative charge. So in between these two plates, we are going to give an insulator or a dielectric material. So for designing a parallel plate capacitor, the formula is C equal to K into epsilon naught A by D, where K is nothing but a relative permittivity or else epsilon naught, and epsilon naught is permittivity of free space, and A is the area of the plates, okay, and then D is the distance between the two plates, that is positive plate and negative plates. So this is what the formula that we are going to use for designing a parallel plate capacitor. Next, so we need some design parameters for designing parallel plate capacitors. Here, I am going to take the dielectric constant value R as 1.000059. Okay, here I am taking the dielectric material as R, and then the length of the dielectric as well as the plate is 20 millimeter, and the distance between the two plates. The distance between the two plates can also be say as the height of the dielectric material. It is 2 millimeter, and then the breadth of the dielectric or also metal plates is 20 millimeter. So these are the design parameters I have taken for designing a parallel plate capacitor. So in this video, I have taken R as a dielectric material whose epsilon R value is 1.0059. So you can take any other materials like mica, glass, or any other materials for designing your parallel plate capacitor. So for manual calculation, we have an online tool called antennacalculator.blogspot.com. I have mentioned this link in the description box as well as the comment section. You can check it. I also provided the QR code in the video. You can check it. So I need to visit antennacalculator.blogspot.com. So here in the first page, you can find parallel plate capacitor calculator. You need to just click on here. So after clicking this, you need to enter the relative permittivity. So I have already figured the area of the plates in meter square as plus the distance between two in between plates. So here you need to enter the epsilon R. So the epsilon R value is 1. Okay, for R, the epsilon R value is 1. After giving my epsilon R relative permittivity value, I need to give calculate capacitance. So here I have received a step-by-step calculation of how they have done the mathematical manual calculations. Okay, so here I have done. So let's start with this manual calculation. Let us start the simulation. So here I have opened ANSYS Electronic Desktop Student. Okay, so after opening this, you need to click on File, then New. So after clicking New, you need to click on Maxwell 3D. So it's opening right now. So after opening this, you just need to click on View Project Manager, and then so that's enough. We need to view the status bar as well as the project manager. So let us start our simulation. So you need to first click on Maxwell 3D solution type. You need to set up the solution type to electrostatic. I am just clicking the electrostatic and give OK. So after clicking electrostatic, we need to first create the negative plate. Okay, so the first what I'm going to do here is click on rectangle, and then before clicking the rectangle, click on orientation and then give trimetric so that you can get the proper view. So after clicking this, you need to click on rectangle, and then you click on the axis, and you can draw the rectangle of any size. We can just change it right now. So after creating the rectangle, you need to change the name. Okay, so I'm changing the name to negative plates. Okay, so negative underscore, I am assigning a name. Okay, you can assign any name to it. Okay, so I am assigning this negative plates. So after giving it, click on apply and then give OK. So for negative plates, I need to give the dimensions. Okay, so I'm giving the dimensions here as x size 20 as well as the y size is minus 20. Okay, so I've just given it. Click on apply and then OK. After it, you need to give fit all. Okay, So here we first we have given the negative plates. Then we need to assign some value to this excitation to the negative plates. For that, click on right click and then assign excitation voltage. So for negative plate, we are going to assign 0 voltage. So value is 0, and then instead of millivolt, need to click volt, give OK. So we have successfully assigned the excitation for negative plates. Then next we need to create a dielectric material. Okay, so for dielectric material, we need to create a box. Okay, so here I will click on the draw box option, and then I will just dragging the rectangle. I will drag the rectangle. So we need to rename this as dielectric. Okay. So I'm renaming it right now, dielectric. And then here I am going to give the dielectric material as vacuum. Okay, as I already mentioned in the PPT, I am mentioning it as air. Okay, so you need to click on edit. You can give any material like glass, mica, any other dielectric material. So here I am going to give it as air, AI or air. Okay, so I am giving just clicking on air. Okay, so here I have just give on apply. Okay, so here I have given the dielectric material. Next we need to create a positive plate. For that, just click the rectangle here and then drag it. Okay. So for negative plate, for dielectric, we need to assign the dimensions. Okay, so minus 20, y size is minus 20, and z size is 2. Okay, so already we have mentioned the distance between the two plates is 2 millimeter. So that we have assigned the 2 millimeter for the dielectric material. Okay, so I have assigned it for here. Okay, then I have created a new rectangle. So this I can rename it as positive plate. Okay, positive underscore plates. So I'm just renamed as positive plate. Click apply. Okay. So I need to check the dimensions for positive plate. So x size is 20 and y size is minus 20, and the position is 0, 0, 2. Why we are giving here 2 means, so because we have a dielectric material. So above the dielectric material, we have a positive plate, and below the dielectric material, we have a negative plate. Okay, so that I have given the position of the positive plate as 0, 0, 2. Okay, so click on apply. Okay, so here we need to assign excitation for positive plate. So for positive, click on positive plate, right click on it, assign excitation, voltage. Here you need to give the voltage as 1 voltage. Okay, here you need to give the voltage as 1 voltage. Okay, so I'm just instead of millivolt, I'm just giving it as volt. Okay, so here I am giving it as voltage. Click on OK. So after giving OK, I have successfully assigned that V1 voltage V1 and V2 for positive and negative plates respectively. As you can see here in the Maxwell Project 65, Maxwell 3D design excitations as voltage 1 as well as the voltage 2. As you can see, the voltage 1 below the dielectric material and voltage 2 above the dielectric material. So you can give the colors also to the dielectric material. Okay, so for positive plate I can give one color. Okay, for dielectric I'm just changing the color so that you can easily identify. For dielectric I'm just giving the color as pink color. Okay, so I'm just giving the color as pink color, and then for negative plates I'm giving one color. Okay, so you can also change the color. Okay, for easier identification. Okay, so for it I'm giving green color for negative plates. Okay, so for negative plates I'm giving green color, and then for positive plates I'm clicking on positive plates and I am giving any other colors, like I can give orange color. Okay, click on OK, apply. Okay, so as you can see here, I have given different colors for different materials. Okay, so for different things. So now we have successfully designed the just click on trimetric to get the original view. So next we need to assign matrix form. So click on parameters. Okay, in the project 65 Maxwell 3D design 1, click on parameters and then assign matrix. So you need to click on voltage 1 and then the voltage 2. Click OK. So after giving this, we have in the parameters we have matrix 1. Then you need to give one analysis setup. Okay, so here you need to click on analysis, click on add solution setup, and then just click OK. So after giving this, you need to check whether our design is correct or not. So for that, click on Maxwell 3D, then validation check. So here we have a green tick mark. If any of them get cross mark, then you have made some designs in the steps. Okay, so we have designed correctly so that you can get a green tick mark. So just close it. Next, we need to give the analyze all. So click on Maxwell 3D, analyze all. Okay, so I'm giving the analyzation right now. Okay, so if before that you need to save the file. Here I'm saving the file as parallel plate capacitor. So click on save. So after saving, our simulation will start right now. Okay, as you can see the progress right now. Okay. As you can see here now, our simulation is running on right now. It will take around 1 minute for simulation. Okay. The simulation part is over. Okay. So now we need to check the capacitance value. So click on Maxwell 3D, results, click create electrostatic report, data table. Here you need to click on C, that is capacitance, and then new, click on new report. So here we are getting the capacitance value in picofarad, which is nothing but 1.771900. So as you can see in the manual online calculator, that is parallel plate capacitor online calculator, we have given the relative permittivity value. Here the value manual calculation we have done is 1.77. So nearly both the values we have simulated value and then our manually calculated value using this tool was same. Okay, so this is what the steps we have used for manual calculation. Okay, so you can give any relative permitting in this for this calculation. Okay, so here we are both the values are same. So hence we have successfully designed a parallel plate capacitor. Okay, thank you so much for patiently watching this video. And finally, I like to say one thing. If you are not updated, you will be outdated. So I kindly request you all to update yourself with latest emerging technologies. For that, our JK kindly share, like, and subscribe to our JK Tech Solution YouTube channel so that you can get notified about the latest emerging technologies, tools, and you can learn softwares like ANSYS, Maxwell, HFSS, and so on. Thank you. Have a nice day.